In today's lesson, you will learn how to write triangle congruency proofs when the diagrams given are a little bit more complicated. For example, they contain overlapping triangles. When your diagram contains overlapping triangles, there are 3 steps you want to follow. Make sure to copy these down on your notes. Step 1 is to look for a side or an angle that is shared by both triangles. Step 2 is to pull your triangles apart, to draw them separately. And step 3 is to, from there, continue the proof as normal. Generally speaking, this will mean writing a flow proof like you've done for the majority of chapter 4. And it will usually mean ending your proof with a theorem like SSS, SAS, ASA, or AAS. Let's go over the first proof together. So in a lot of ways, your proof is going to be exactly like what you've done in lessons 4.2 and 4.3 and 4.4. If your given has congruency facts about 2 or more different pairs of congruent sides or angles, you want to split them up. So visually that shows you that you need only one more pair of matching sides or angles to be able to prove your triangles are congruent. Now, step 1 that you copied down earlier said to look for a shared side or angle in your 2 triangles. To do that, you need to figure out which triangles we're talking about because there are so many different triangles in your diagram. Are we talking about this one here compared to this one? Are we talking about the middle one? Which triangles are we trying to say are congruent? So read the proof carefully. The first triangle that we're trying to prove congruent to the second triangle is ABQ. So find ABQ and highlight its sides. Then choose a different color, find BAP, and highlight the sides of that triangle. BAP. Do you see a side or an angle that's highlighted twice? See how side AB is highlighted in 2 different colors? That tells us it's part of both triangles, so you can add a congruency mark there. It's congruent to itself no matter which triangle you're looking at. And you can say that AB is congruent to AB because the reflexive property. Now, to do your last step, please pull apart your triangles. So see the purple triangle and the yellow triangle, pull them apart and draw them separately. And when you do, label the corners. So for the purple one, it's Q, A, and B. For the orange one, it's A, B, and P. Now that you've pulled your triangles apart so they are no longer overlapping, you can add congruency marks to represent the given. Those 2 matching angles, QAB matches PBA, and that given that AQ is congruent to BP, and what we figured out from the diagram that AB is congruent to itself because it's part of both triangles. Now that you've pulled your triangles apart and added congruency marks, you can work on your last step of the proof. You can say triangle ABQ is congruent to triangle BAP because if you label your sides, angles, and such, the SAS postulate. Let's try the second proof. Go ahead and use the information from the given. We have 2 pairs of matching sides and angles that we already know about. We need 1 more to get 3 total. So let's figure out what side or angle our 2 triangles share. There's a lot of different triangles in the diagram. To figure out which ones we're talking about, let's highlight the ones in the proof. LNO is this one. PNM is this one. Take a moment to highlight your triangles. Do you see a side or angle that is fully highlighted in 2 colors? Angle N is on both triangles. It's highlighted in two colors. Notice how there's no side that's fully highlighted in two colors. Like, see this blue side of the triangle, side MN. It's overlaps with side LN in the purple triangle, but they're definitely not like fully the same side. So that doesn't count. It has to be a side fully highlighted twice. The only thing fully highlighted twice this time is an angle. So you could say angle N is congruent to itself because of the reflexive property. See how it's a corner for both of your triangles. Now you could pull your triangles apart. And label the matching sides and angles with congruency symbols. So the given told us angle L is congruent to angle P, and that side PN was congruent to side LN. We also figured out that angle N was congruent to itself on each triangle. To prove the triangle's congruent, which theorem or postulate would you use? ASA. Try the third proof. Pause here and see how much of it you could figure out on your own. You have your given. You look at the proof to know which triangles to highlight. That's especially important in this proof because there are so many different triangles that could be congruent in this diagram. But they're talking specifically about triangle TJR and triangle KRJ. Is there a side or angle that's highlighted twice? If you said RJ, well done. Reflexive property to say something is congruent to itself. And then pull your triangles apart. Label all the congruencies you know, either from the given or that you were able to figure out from the diagram, like RJ is congruent to itself. To prove your triangle is congruent, which theorem or postulate would you use? SSS.